get going. I'm not sure I've met everyone in the room, so I'm Jeff Parker. I'm in our mechanical operations and systems engineering group. So today we've got Kurt DeMaagd, and he's the Chief AI Officer and co-founder of Sight Machine. And the way that this company came to my attention was kind of interesting. I was on a World Economic Forum Global Future Council for Advanced Manufacturing. Say it 3 times fast, and you will garble that. But they have these lighthouse programs for innovative companies, and Sight Machine was one of those whose technology was kind of held up as something that could be really transformational for lots of reasons, for operational improvement, for energy savings, for operational equipment improvement, lots of things. And so I've interacted with John Sobel, who is Kurt's co-founder, for a few years now. And then Varsha Shukla actually had the idea of inviting her for the John seminar because she went there on a summer internship. So that's how Kurt comes to us. He actually started in academia, took a doctoral degree at the University of Michigan, and then was an assistant professor at Michigan State University. And then he took a slightly left turn, or a right turn, if you look at it, and ended up joining John as a co-founder, and that was about 12 years ago, as I understand. So that's about as much as you should hear from me. The floor is yours, Kurt.
All right, yeah, thank you. Yeah, certainly thank you for inviting me here today.
Do you have your microphone?
Yes. Hopefully that, I don't know if it'll pick up, maybe I'll. Got a PhD, but can I use a microphone? We'll do it that way just in case so it picks up better. All right. So yeah, thank you for inviting me here today, giving me the opportunity here to talk a little bit about some of the work that Sight Machine has been doing. And a lot of what we do is managing data. We're a data platform for manufacturing companies. And a lot of that does involve work in artificial intelligence. And of course, these days, you can't really do anything in AI unless you can also talk about large language models. And so pretty big topic for us, seems like a fairly timely item here. Here to talk to you a little bit about some of the architectures that might be useful for doing this. Once you potentially graduate, go out the real world, whatever you want to call the world on the outside here. I also have a little bit of a ulterior motive here because I have an opinionated view on how you should be using large language models, ChatGPT, whatever else you have, and that is actually as knowledge orchestrators. So that actually comes from a slightly deeper concept too, which is how you even use AI in general. So even if you don't care about large language models, what I'm going to talk about is using AI as one component in larger systems of many AI smaller applications and chaining those together. And a lot of people who are AI enthusiasts, machine learning enthusiasts, the traditional sort of approach to tackling these problems is, well, first you get your data in order, then you take that and push it into your favorite machine learning algorithm, and then you get some results and, show charts and hooray, everything's done. But a lot of sort of real world problems, if you get the really complex problems, it's never that easy. You're often taking one model, taking results from that, pushing it into another model, results from that, pushing it into another model, and so on and so forth. So to take this out of the LLM world a second before I get into my real slides, an example that we worked on, one of my favorite examples we ever did, was trying to study alarms coming off of machines on a production line. And you might think, of everything you might have learned in, say, a mechanical engineering course or something like that, that these signals coming off the machines are, of course, well designed and well engineered. In practice, they're terrible. They're just a whole bunch of noise. And so we were trying to solve this problem of figuring out which alarms really actually, for real, signal that the machine was about to go down. And to do that, we had to do a series of things like cluster analysis, where we were taking sort of the different alarms that may or may not be going off in certain cases. So we were doing cluster analysis. We used a little bit of natural language processing on those clusters then to figure out which components in that cluster were the real items, and we passed it on to a sequence analysis to actually trace back in time to figure out which was the original root cause, and things like that. And so you're actually doing algorithm to algorithm to algorithm. And so one thing that I hope you kind of get out of this at a very sort of high sort of meta level is you don't need to just think about machine learning algorithms as data comes in, magic big monolithic box, results come out, but you actually may want to chain things together. So anyway, that's a brief spiel. Let's actually get this back down to large language models here. Oh, I should add one more little brief comment here. Sight Machine, we work with manufacturing. That does shade my opinion on a lot of this quite substantially. And so with manufacturing, you are talking about requirements for very high accuracy. And so you can imagine that when you are working with a production line, these are systems that can be both costly if you make a recommendation that is incorrect. You could be increasing scrap, you can take the line down, cause a lot of expensive things, even to cases like we work with a lot of glass manufacturers, gigantic glass furnaces. Well, you get those wrong and you burn a hole in the side of the furnace and dump a couple 100 tons of glass onto what used to be the floor. And so clearly there are reasons why this particular audience that Sight Machine is trying to serve cares a lot about accuracy. And of course that accuracy flies right in the face of one of the big problems with large language models of the hallucinations and some of the accuracy problems. So, I get maybe a little bit definitely strongly emphasize the accuracy side here. You'll see that here. Other applications may not require that same accuracy. If you get your pancake recipe wrong in the morning, slightly less consequences than dumping molten glass on the floor. But for what we're thinking about here at Sight Machine, we really, really, really care about accuracy and how you ensure that your models are accurate. So anyway, let's dive into what that actually means. So a slightly underappreciated concept about large language models is that they are actually really good at processing language. Now, you might think, well, that's kind of weird, to actually have to say. But if you look at a lot of the common sort of, we'll call it the media coverage around this idea, we do start off from a good place, which is large language models are great at generating human-like responses to questions. Okay, so we're starting in a good place. That's great. And large language models are typically, by virtue of being large, trained on a lot of different topics. You basically, you crawl the entire internet, train up things on a lot of different topics. And what's often sometimes underappreciated, there's a lot of tooling that also goes into your large language models. It's not just sort of predicting text. One of the best ways that you can actually see that with a typical large language model is you go into, say, ChatGPT and ask it, what time is it? Well, it doesn't know what time it is by having mined lots of text on the internet. In fact, I would actually be kind of curious to see what the answer to what time it is if it's just predicting off of text on the internet. But there is sort of a special sort of tool skill in the background of a large language model that knows you just asked it about time. They would like to know what time it is. Computers know what time it is, so I can report that back to you. So you have all these additional skills that are kind of in there. And so you get this ability to answer lots of things in a human-like way. And that then starts to lead to the sort of other logic that, language has often been associated with intelligence. In fact, the sort of classic argument up until about 18 months ago was artificial intelligence isn't actually intelligent because we can't understand things like sarcasm in language. Computers can only understand the sort of plain text understanding of language. And so therefore, until you can understand sarcasm, you aren't actually intelligent. That's one of the classic examples. Now, of course, the funny thing is now you can go into, say, ChatGPT and ask it to tell you a sarcastic joke, and it will tell you a sarcastic joke. And so suddenly everybody's, it must actually be intelligent. And so if we put all these pieces together, people are suddenly saying, okay, you know what, look at this. It is making intelligent-like responses to all sorts of other, questions and all sorts of topics, so it must be fully intelligent, and that then leads to all the, LLMs are going to take over the universe and all that sort of stuff. Of course, now as we've seen over the last few months, there's now a lot more pushback on this sort of idea, the hallucinations. People are appreciating that, hey, this doesn't necessarily work. And especially for us, like Sight Machine working in the manufacturing space, as I said, the consequences of getting things wrong are very, very, very problematic. So that's kind of led us at Sight Machine to say, let's step back a little bit, and can we get back to basics? And rather than let the large language model try to do all of our analysis, let's use it as just one piece in the puzzle here. And it is great at processing language. And so where does language processing come in when you're trying to do analysis for things like, enterprise-grade tool? And so, just a slight diversion here before I get into answering that. So what that has resulted in is a lot of places that basically treat your large language model as a singular app. And as I said before, that the singular app model has a lot of limitations. If you look at a lot of data products these days, everybody has done something like the fuzzy SQL type of thing. So you can type in sort of a question in sort of human speak. It will, in the back end, translate that into SQL, run off, query the database, give you an answer back. It does turn out that there are some problems with that. You have to be a little bit careful with that. We see some very interesting, somewhat funny results when you just do sort of unfact-checked versions of this. For example, if you were to ask it to write you a query about, what was my output per day for the last quarter, I believe even today, ChatGPT will interpret the last quarter as the last 3 months today, whereas in business parlance, when you're saying the last quarter, you probably mean a fixed 3-month interval of time. And so we're in, fourth quarter, at least calendar quarter. If you meant last quarter, you probably meant the previous 3 quarters, not a sliding window. So sometimes you get that context wrong, as you need to still be able to go in and sort of intercept problems like that. You also still have some cases where you have to be a little bit careful, like where the human language is somewhat ambiguous. A fun example might be if I said, let's go have coffee next Saturday. What is next Saturday? Well, to some people, next Saturday is for us tomorrow. To some people, they would say, oh, no, tomorrow is this Saturday, and next Saturday is the Saturday after that. And people will debate at a sort of English level what that is. And so if somebody then writes a query in that same way, how do you interpret that? So there are actually problems with doing things like the fuzzy SQL. There's automatic code generation that we're seeing a lot of out in the field. I believe actually you have a faculty member who also works with Databricks. Their code generation tool is pretty cool. I love Databricks. So that's a great idea. And I could get in trouble for saying this. It was on the slide. If you aren't using ChatGPT to write code, you're doing it wrong. Now, there's a little bit of trouble. You should probably learn to write the basics of code so that you can identify when it's doing it wrong in the first place. But the acceleration, I mean, you don't need to do special stuff, have special tailored tools. Just go type it into the ChatGPT client or Bing AI or something like that, and the results, it accelerates your work. It's pretty amazing. So, I mean, you have tools like that. Of course, in the more corporate space, sales and marketing sort of material generation. I should actually call out Varsha's internship with us over the summer, created this kind of neat little app. In fact, did I screenshot it? Little screenshot of what we were working on. This is actually a tool for our sellers to help them as they're preparing to go to a customer site. And so you might want to have things like, know some basic financial metrics, but also things like strategic priorities. If you're going to talk to Coke, would you like to know, do they care about energy efficiency, or are they interested in scrap reduction, or things like that? And so kind of a cool little app where we can mine the internet, find information from their corporate website, public information filing, stuff like that. Put that all into a nice little application and pop that into this, and so our sellers can ask questions there. So kind of neat little things like that. But this is all stuff still in this general sort of framework of LLMs just as this one monolithic thing. And what I would like to do is show you the sort of new area where we're seeing it as an orchestrator of many different tools. And that's really where this language idea comes to play as a huge accelerator. So although large language models have a sort of spotty-ish history when you're asking it to do things like, give you factual answers or to correctly apply logical reasoning, things like that, that's not so good. But what they are really good at is taking lots of different, especially text, bringing that information together, picking the right sort of sentences that you most care about, and matching that to a question that you are asking to come up with a great answer. And so you don't have to be a domain expert. You can actually write a question. ChatGPT can understand what are you actually asking for, route that to other systems which are specialized at answering it, accurately answering it, aggregate that information back, and then turn it into a human-friendly response. And so I'll give a little bit more on this idea in just a minute, but that's what we're going to look at ChatGPT and LLMs in general as doing, just serving as that language layer, understanding what the user wants, and then also returning the result back in a way that's going to be very sort of human-friendly, human-compatible. And just in case you think, oh, well, this is Kurt's silly little minor idea here, for those of you who are familiar with things like the Microsoft M365 Copilot, this is sort of supposed to be Microsoft's across your entire enterprise. You could be sitting in Excel, ask it a question, and if you're a Sight Machine customer, it should be able to take that question, say, oh, well, this is information about your manufacturing plant floor data. I'm going to get information from Sight Machine, pull that over, bring it back to you in Excel, and oh yeah, you just asked a question about sales, so I'm going to go over to your Salesforce data, pull information over there, pull it back, all that sort of stuff. So this is a way to bring all of the information in your enterprise together through at least Microsoft's Copilot program, and depending on which analyst you ask, the estimate is that's going to be $10 to $20 billion of revenue for Microsoft, I believe starting around 2025, they think so. So big dollars around this idea of a Copilot being that initial interface with lots of other skills sitting underneath. All right, so what does that actually look like? Here is my lightweight architecture. And we'll kind of break this down here over the course of the next, 20, 25 minutes or so. But basically, as you can see, we can start off with a user who can ask a question. You go to this orchestration layer, which is going to look at the intents of the user. What do they really want? And this is one of those things that actually ChatGPT is eerily good at without being a domain expert, kind of figuring out that, hey, you're not a statistician, but you're trying to do some sort of like inferential analysis question, or it's just a summary question, or things like that, or you're asking about this specific machine. It's actually really good at that. And so it can pull apart that question. Then you can use additional logic to say, oh, well, this type of question needs to be addressed by domain skill number 1 versus domain skill number 2. Route it down to there. Those domain skills can then go either pull data, can reference other machine learning models, etc. So anyway, this overall model here, some of you may have heard the jargon retrieval augmented generation, RAGs, or sometimes it's also called data augmented generation. It's basically RAG or DAG sort of on steroids, but instead of getting that sort of retrieval coming from, say, a web search or something like that, the retrieval is coming from expert nodes which are pre-validated that already know how to answer that question. And so, anyway, let's break this down a little bit further and what it takes to actually make something like this work. So, before that, once again, a little side note on an approach that is almost always incorrect. And so I should be a little careful when I say almost always, there are use cases here. But there is a little bit of hype around, hey, should you custom generate an LLM of your own? There is a place for custom-generated LLMs. At lunch, we had sort of an interesting conversation about, I guess we could call them small language models too, and how those could also be a nice little piece of the puzzle. But some people are sort of thinking, well, shouldn't I just take my entire corporate knowledge database, dump it into one gigantic LLM, and then you can get the results that you're looking for? Well, there are a couple concerns with that. I mean, one, of course, is as much data as you have, a large language model is pretty darn large, especially if you want to get the benefits that you kind of see off of, ChatGPT, things like that. Its ability to answer so many things comes from that massive breadth of information. So if you're just feeding it your corporate information, you might not get the results that you're looking for. Also, it is a large language model, and so that means that it's going to take a lot of compute, which means a lot of compute time, which also means that you're probably running this at some gigantic data center, which is, potentially horrible for the environment. There are some interesting concerns right now around whether it's even ethical for a lot of people to be training up these large language models. Entirely separate topic, fascinating topic. We won't go down that road today, but it is sort of an interesting problem. And then, of course, as I mentioned before, there are additional tools that you get when you're using things like a ChatGPT, Bard, Llama, whatever else that you aren't going to get if you're just training up your own model. So this sort of ability to answer basic questions, to do logical reasoning, that's often actually a separate custom-developed tool, not just predicting text, predicting the next word. So not saying you should never, ever, ever custom develop your own LLM, but honestly, there are better approaches. So for example, you can build off of sort of fine-tuning models built on the major models that are already out there. But having said that, I also, this is a little bit more dangerous opinion, think that's almost always the wrong answer too. The reason why these fine-tuned models are sometimes wrong, they're better than creating your own model, but sometimes wrong, is it still takes a fair amount of time to do these, and so you're not going to get real-time information. And okay, yep, not every single problem in the world needs to be solved by real-time information, but a lot of the pushes for data these days, sort of in the sort of corporate environment, is all about having that real-time information to react, to get those sort of fine little, the low-hanging fruit has been already harvested. We need fast, accurate, timely information for decision making. And if you're constantly waiting to retrain fine-tuning models, you're not going to support that use case. The other thing that's a little bit weird with these fine-tuning models, it's just kind of you're dumping your data just into the large, the gigantic bowl of soup anyway, and differentiating your custom data from the larger data set can be difficult. And so if you want the language model to respond only with the information you want it to respond with, it's much harder to control that because you're just sort of undifferentiated goo within the model. So that's what sort of led to our approach here. So anyway, the first step, if you want to do sort of this more retrieval augmented / expert domain skill augmented generation here, is number one, you need to get your data in order. And this is, very, very, very important. I think a lot of folks, when they're thinking about machine learning, they first go to the algorithms. But as we all know, sort of garbage in, garbage out, data is the core of good machine learning. In fact, I kind of like to think of this in terms of like coffee. And what is the number one ingredient in coffee? If you want to have good coffee, how do you get good coffee? I'm slightly obsessed with coffee, I'm sorry. So how do you get good coffee? A lot of people say good coffee beans. But coffee beans are not the number one ingredient in coffee. And I'm also not talking about those weird people who pour like half the bottle of creamer into their coffee either. That's just gross. I mean, if you want good coffee, you start with good water. And that's the same principle here with AI. If you want to have good machine learning, you start with good data. Now, of course, some of this is traditional sort of garbage in, garbage out type of stuff with your machine learning that hopefully everybody here has had slightly beat into them. But there are still some tricks that actually make sharing data with your large language model just that little bit more effective. So, for example, I actually like to sometimes do what I kind of call sentencifying key facts. And so instead of just taking a bunch of numbers, kind of in like a comma-separated file, you know, your major technologies like ChatGPT or Bard can usually kind of parse those, but they lose some context. And what's really funny, if you do examples like I have kind of up there on the right, just create really, really boring sentences, like, you know, on November 9, 2023, at 1400, the average open crown temperature was 1390 degrees Celsius, and feed it a bunch of these incredibly boring sentences. What's kind of funny is it does a little bit better job of understanding what you want to do with that data. Maybe some of you all who have a better theoretical understanding of how these work might be able to give me a better answer, but I do really think part of it is just you're providing much more context. It's a more information-rich payload when you feed it this information in this sentencey format. And so that you've got, you know, additional words. And I think that it just sort of picks up, it's able to match that context a little bit more effectively. So kind of a neat trick that we found to improve the accuracy and responses here. So sentencifying, kind of a fun thing. Now, obviously, that is not a efficient way of storing your data, so there are some challenges with that particular approach. But nonetheless, it's kind of a fun little trick here. Other things, I don't know how much you have necessarily talked about different data formats, but a wide format as opposed to a tall format is generally good. So if you think about the traditional data science record format, you might have a nice panel data set where every row is one timestamp, and then the column is going to be, you know, you got your temperature, your pressure, your humidity, types of things on the columns. Now, in fact, probably most of you are used to working with that data all the time. The funny thing is most manufacturing data actually is stored in this long format where every row it goes with the form timestamp, name of the parameter being measured, value being measured, and maybe some additional items on that. It's actually terrible for machine learning. It's terrible for ChatGPT. So pivoting that around. It's also kind of funny with the wide data trying to get things joined together already, because ironically, although ChatGPT is excellent at writing SQL, it will not join your data. Well, it can do some very basic lining up, but yeah, it's not going to join your data itself. It is not a database. It is not intelligent in that way. So although it knows how to write SQL, you have to join your data yourself. So get your data joined and ready in a format like that. And of course, there's lots of plugins and stuff that can help with reading different data formats. But you do have to watch out. We had sort of a nice conversation earlier about business and strategy around large language models. And there were some interesting people rushing into the sort of plugin space of how do you get more data types ready for ChatGPT. For example, there are a few businesses that said, "Ooh, I'm going to make it easy to take PDF data and feed that into ChatGPT." And then about 2 weeks ago, I believe, OpenAI announced that they're natively going to support reading PDF files. And so they took a couple startup businesses and just shot them. So it can be a little dangerous when you're in these sort of areas where an organization like OpenAI could quickly and easily move into. And so you got to kind of watch out for that if you are thinking, hey, I want to start a business here. So anyway, I do need to keep moving. So, all right. So next step here, we're going to create skills based on that data. So these are specific modules which can handle specific types of tasks. Now, some of these are going to be things like machine learning models. So you might have a special skill that can handle root cause analysis for downtimes, or you might have a special machine learning model that could do predictions for scheduling purposes or things like that. So you could have machine learning models. Sometimes these are going to be fairly simple modules which just know how to correctly work with the data that you have at hand. Sorry, I should go to my next slide here. And so there's a lot of different approaches here, but the fundamental idea is these are tools which are going to do the actual data analysis. In fact, up on my slide, I give you sort of my 11th commandment, thou shalt not alloweth an LLM to analyze thy data. Now, that can be a little bit harsh because, okay, they can kind of do some basic math and stuff like that, but the more you rely on the LLM, the more easy it is to get tripped up on, frankly, very easy types of problems. Now, some of this is, of course, they have limited capacity to do certain types of analysis. Sometimes it just plows ahead with stuff which is wrong, but it would never actually know that because it lacks the context. And so a classic example at Sight Machine that we face is aggregating KPIs, key metrics from the plant floor. And one of my favorite examples is quality. So take quality, fairly easy metric. It's basically percentage of good parts that you're going to produce. Well, if you start off with, say, a database which has quality by day, and you want to know what was the quality for the week, if you just say, hey, what was my average quality for the week, give that to something like ChatGPT, it's going to average your daily qualities. But hopefully you all remember from your statistics class, the average of a set of averages is not the same as averaging the entire data set. So for example, maybe one day you made 5 parts and you had 100% quality, and one day you made 1,000 parts and you had 50% quality. That doesn't mean that your weekly quality is 75%. It's, well, I already forgot my example, but you can do the math. So you have to watch out. But you can actually create a specialized skill which knows about the foibles of your data, knows how to properly aggregate it, so when that higher level orchestrator says, showtime for you, it can correctly set up that data for you and give a correct answer back to the end user. So, the other big thing is by breaking this down into all these smaller modules, you can start to actually validate these modules and make sure that you're giving good, accurate results out of them. So instead of relying on ChatGPT to hopefully come up with a good answer, by creating your separate modules, it's going to go through, you can take that machine learning module separately, show results to the end users, make sure that it's giving the types of answers that they would believe, goes through that whole validation process. So you're breaking things up into nice little manageable chunks here. So, we create those skills. The next thing that we have to do is we want to track and trace all of your data flows going through this system. So security is, of course, a key problem when we're thinking about this in the enterprise environment. We want to be able to know, okay, if a message gets all the way to the end user, is that end user actually allowed to see that data? So we may have to actually have filtering to make sure that users aren't just sort of using the machine learning model to bypass things like that. So we can add security for row-level access control. We can add security for certain apps. And this actually was a bit of a problem a few months ago when OpenAI tried to do their first sort of retrieval augmented version of ChatGPT. So of course, as many of you know, the sort of original ChatGPT models were about a year out of date for the types of questions they could answer. So they wanted to be able to do kind of like the Bing AI chat where it goes over to Bing, does a search, gets those results back and augments the results with those that information. Well, apparently they had certain ways where it could get information beyond certain paywalls from certain websites, and some rather astute users then said, aha, I don't have to subscribe to such and such a service. I'm just going to ask ChatGPT to tell me about something that's in this service, and you could bypass that. So OpenAI had to very quickly take their system down. The new version of Retrieval Augmented is now smarter about that, so you can no longer bypass paywalls with it. But that's the sort of thing. You have to know where your data is coming from so that you can actually ensure proper security, that people who are using this are allowed to do it. Second thing that's sort of related to this track and trace, it's going to improve the queryability, by which I mean you've got all this data, and so far we haven't really talked about how we pick which data bubbles up to the higher levels. And so if you know where the data came from, that helps you sort of filter things out. So if in the Sight Machine case, if we know that this particular data came from a certain furnace on the production line, and we know that the user is asking for that furnace, then of course we're going to let that go through. But if we see other data that came from, I don't know, a washer or something like that, then we know not to feed that data up. So it helps with the queryability, and perhaps most important, it allows you to actually create this audit trail where users can then build confidence that what finally came through the large language model actually was important and accurate for them. And so I think I put a screenshot here. I apologize, it might be just a little bit small on your screen, but this is an example of what we sometimes do, where you can ask it a question. I just had to give a short little question here in the bottom right corner. Give me a basic root cause analysis. And at the very end down here, there is a nice little hyperlink. You click on that, brings you to a page which has some of the supporting underlying data for those claims. And so that way, maybe you don't believe the answer, or maybe you just want to, I don't know, just sort of see it graphically or something like that. That track and traceability lets you take the answer, tie it back to the original sources so that you can build that confidence in the results. So handy little trick. And the other thing is it is actually kind of cool, especially with ChatGPT, how easy it is to do that. If you're creating your prompts that you're going to then feed to the final LLM model, you just number every sort of fact that you give it, and you tell ChatGPT, provide references for every fact that you use, and it actually will give you those references, those reference numbers. And so all we have to do is turn it into a hyperlink. So it's kind of cool how easy that actually is. So, people give ChatGPT a hard time about the accuracy, but they do provide some nice mechanisms for hopefully getting your traceability available. So anyway, I've been talking all this time, okay, I think I'm a little better in time now, about all these other things except LLMs. So let's finally talk about where the LLMs fit into this equation. So when we set this up, we do want to make sure that we're using our system prompts, which are our best friends. And so typically, if you are just using the chat client to play around with ChatGPT, you probably can't use it. I believe ChatGPT just released a new sort of machine learning studio sort of environment where you can actually play around with the system prompts. But system prompts, especially once you get to things like GPT-4, it actually finally respects your system prompts. And these actually create the sort of framing that the LLM is going to use when it answers your question. And so they're a lot of fun to work with and make sure things give you the right answer. But the quirk is, if you've ever done any sort of programming with things like this, sort of programming a large language model, I like to compare it to trying to explain to my 13-year-old daughter what I want done. You have to use very basic English, but if you just sort of lay it out, basic sentences, what to do, step by step, it actually can do some pretty crazy sorts of things. Now, some of them are a bit weird. So I did kind of give an example. When we get a question, one of the most important things we want to know is what machine on the production line are they talking about? And what's funny is ChatGPT does a great job, even though it's not trained on manufacturing data. If you ask it a question about a machine, it picks the machine out really, really well. I don't get how it's so good either. There must be enough manufacturing data in its training set. But what it doesn't do well is consistently format the response so that we can then take the response from the LLM, just do a basic regular expression, pull that out so then we can use that for everything else. So what we actually ended up doing is, although just like a one-sentence statement, what was the machine in the question, blah, 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 actually gets the answer right, we have to go through all these silly additional steps in order to actually give us a response which is consistent, which is this very bottom thing. We want to get this machine name right here out of it. And so by breaking it up, giving it lots of extra contents, by splitting it into two questions, it sounds weird. We completely ignore question number one, but we have to ask question number one, or it gets the answer to question number two wrong. I don't get it either. But you do that, and hey, it actually kind of works. Anyway, this isn't a prompt engineering lecture here or anything like that, but you can do weird things like that. You just have to really think about how do you explain your problem like you're talking to, my 13-year-old daughter, and it works a whole lot better. So get your system prompts in order, and then finally we get to the stage where we care about I call it languageification. Where we actually take all of our data, turn it into this human-friendly sort of format. So how do we work with the language? And actually that does come into the two different steps that I alluded to before. You've got understanding the user's intents, which ChatGPT does a wonderful job of in terms of trying to extract out. Of course, there's time, but machines, material that you care about, etc. And we use that to route to all those specific skills that we created. And then, of course, we can generate our response. So the skills have then returned their responses back up to the LLM and use that to give you an answer. Now, what is also, I think, a great thing about these LLMs is they're multilingual. And so don't forget about that. This is not just a ChatGPT, Bard, stuff like that are also multilingual. And so this has been a great help for us when we work with, say, a plant that is in Mexico. Well, somebody who speaks Spanish can ask their questions in Spanish and then get the response back in Spanish. So it's going to break down a major barrier to entry. So very helpful to have that multilingual component. Another silly trick that you can do is with your responses, with most of these sort of chat interfaces, you can either have it wait until it's composed the whole answer, or there is the sort of chat stream-like option where it streams one word at a time. The really funny thing with this is, for one, if it's streaming, it's giving you the answer sort of in real time. It doesn't wait till it's all done, so you get part of the answer without having to wait. And frankly, most large language models are still a little bit slow. So that helps with that, but also it starts to feel more conversational. And it sort of, once again, gets that human feel coming back into your chat conversation. And to the extent that we're trying to break down barriers to people who were not traditionally a sort of data user, it actually helps a lot to stream a response to them instead of just giving them the answer outright. Just silly little usability trick. And then finally, one of my favorite things to do is actually have it make the answers fun. And so this is actually the reason why I think ChatGPT has been the sort of dominant LLM in this area. Bard is catching up a little bit in terms of these capabilities, but, and you could argue, okay, is Bard better at logical reasoning than ChatGPT, all that sort of stuff. ChatGPT has this weird charisma, especially if you want to do something like take your response and convert it into some sort of song, or to make it in the format of an old-time radio show, or something like that. And it's actually a lot of fun to do this with an end user, where we can start off with something really boring like that little root cause analysis, little mini report, maybe something a little bit longer than that. And, you show that to somebody and say, okay, yeah, it's kind of neat, I'm interested in this particular thing that I identified, I should go fix it. But if you have somebody who's maybe a little hesitant about working with machine learning AI, when you then translate it to a country music song is my favorite sort of gimmick. So take that report, translate it to country music song, suddenly they lean in. It's like, oh, well, that's really cool. And then can I convert this from a country music song into a K-pop song? And you can do it from a K-pop song, and as I said, it's multi-language. So you could actually go to one of our customers in Korea and translate it into a K-pop song written in Korean. And it actually will write it out beautifully. I don't speak Korean, but we have a board member who who is from Korea, and she was laughing up a storm. Because, hey, here's manufacturing data in the form of a K-pop song. So kind of neat. In fact, I gave a little example here. This was from a food manufacturer here, and I asked it to take a root cause analysis report and translate it into a love poem. And I don't know if I should read this, but oh, my dear rappers, you're the heart of my line, packaging my products, making everything fine, that sort of thing. And of course, it's truly ridiculous. At a very tactical level, of course, that, there's no, utilitarian value to doing this. But when you do this, suddenly everybody starts to laugh, and then they want to play with the data. They want to try something. You just broke down that huge barrier to working with the data, and everybody gets super excited. So this is, in my opinion, one of the most powerful things. It's also great for sales, too. Walk into a room and, hey, look at what our technology can do. We can turn your data into poetry. So for those of you who are thinking about starting businesses, this is winner. So anyway, silly applications like that are really powerful. So yeah, let's kind of put everything back together here. Just a reminder, so what does that mean? Yeah, user's going to ask the question, orchestration layer rips that question apart, routes it to the domain-specific answer sort of skills that we know will give you an accurate answer, which of course pulled their data from various raw data sources, machine learning models, et cetera, feeds that back up to the orchestration layer, which can sort of stitch everything back together, taking advantage of that ability to sort of aggregate text and create human-friendly responses, and feed that back to the end user. So you can do that. And then I should also say, you can then take this and make this into a much more hierarchical, multi-level thing. So this level could be just the workflow for, say, your manufacturing plant floor data. You could do another one for your sales data. You could do another one for your finance data, and then stitch them together here, just sort of constantly recursing through this process so that you're just at every level sort of pulling things apart and routing accordingly. So anyway, let's wrap things up here, and I'll open up the floor for questions. So, of course, LLMs, a key way to engage people in, in a way that they have not worked with data before. We see this as very powerful folks who have traditionally said, oh, I'm not a numbers guy, I'm not a stats guy, I'm not going to use machine learning because that's just not the way I work. It's breaking down those barriers to entry. But that said, we have to remember large language models are not some sort of omniscient intelligence. They're much better as something that can be this orchestrator, understanding what's supposed to happen, get the answers, aggregate them back up. In fact, this is being recorded, but nonetheless, I'll say this. I like to make the comparison. The large language model is like an English major. And if you have a data analysis problem, you probably aren't going to walk over to whichever building the English department is and say, I've got a data analysis problem. Can you help me? English department's the wrong place for that. But if you've done a bunch of analysis and you've written a report and you need a consult from somebody who knows how to write good prose, write convincing text, well, that's when you go and talk to your English major friends in order to do that. So this is the same principle. This is a language model. Use the language model for language and use other machine learning models for what they are best at in order to give you those good, accurate answers. Which, of course, start with good data, create your good skills, and then let the LLM craft a response off of that. So I think that wraps things up, and I think I left about 10 minutes for questions here, so happy to entertain any questions or thoughts.